Hello, my name is Nicholas Stewart, and this is my demo video for Experiment 6. Okay, so first I'm going to take the chip 7486IC, which is the chip that has the EX OR gates, and I'm going to place it in the middle of the breadboard. Next, I'm going to connect pin 14 to, let me look in the book to make sure I'm doing this right. Yes, I need to connect pin 14 to 5-volt power. And then I need to connect pin 7 . Oh wait, that's wrong. We actually want to connect this to the plus part of the breadboard. And then we want to connect the ground I'm going to connect the ground to to the negative part of the breadboard. Okay, now that that's done, we can start to connect chip 7486IC to its power and to its ground. So pin number 14 needs to be connected to power. 5-volt power. And pin number 7 needs to be connected to ground. There we go. Okay. Next, I need to connect switch 1 to input A and switch 2 to input B. So, in the chip, we have several XOR gates. EX OR gates. I call them XOR gates. So, pin number 1 is input A of the first XOR gate. Pin number 2 is input B of the first XOR gate. And pin number 3 is the output Z of the XOR gate, the first XOR gate in the chip. So in order to connect switch 1 to input A, we need to connect switch 1 to pin 1. So first I'm going to connect this wire to switch 1. And then we're going to connect the other end of the wire to pin number 1. Hopefully it reaches. Oh, and it kind of popped out. There we go. Okay, next I need to connect switch 2 to input B. So I'm going to connect switch 2. Switch 2 is going to be connected to pin number 2. There we go. Next, I need to connect the output Z to an LED. So I'm going to connect pin number 3 to LED 0. Pin number 3 is being connected to LED 0. There we go. That should do it. Next, we have to perform the experiment and complete the truth table. So I turn on the power. Well, first I make sure all my switches are down, I guess. And then I turn on my power. Okay. So the first situation, according to the truth table, the first situation has A down, B down. So remember that switch 1 is A and switch 2 is B. So A should be down, and it is, and B should be down, and it is. Power is on, but LED 0 is not lit. So in this case, I would put a 0 where output Z is. I wrote 0 here. Next case, input A is down, input B is up. So input A should be down, input B should be up. Okay. That's kind of weird. In actuality, in this case, the light should be on. So I gotta find out why it's not on. Let me make sure my connections are correct. Oh, I found it. I think it was that the ground was not correct. Okay, so in this case, like it's supposed to be, the LED is on. So I would put a 1 for this situation. I would write a 1 for this situation. So now, Next situation, A is up, B is down. So A should be up, B should be down. The LED is lit. That means I put a 1 for this situation. Now the final situation, A is up and B is up. So A is up and B is up. In this situation, the LED is not lit. So I would put a 0 for this situation. These are reflecting the characteristics of the XOR gate, the XOR gate. The XOR gate only produces a high when its inputs are the opposite of each other. Okay, now I'm going to have to construct, for the next part of the experiment 6, I'm going to have to construct figure 6.2, which is shown here. It has two XOR gates, two XOR gates connected to each other in order to produce a XNOR gate. So the first step is I need to construct the basic circuit. In order to do that, I take chip 7486IC and place it in the middle of my breadboard, which I've done already. After that, I connect pin number 14 to power and pin number 7 to ground. After that, it's important that I pay attention to where all of my XOR gates are. So pin numbers 1, 2, and 3 are my first XOR gate. Pin numbers 4, 5, and 6 are my second XOR gate. So I need to connect my first XOR gate to my second XOR gate, just like it shows in the diagram. In order to do that, I'm going to have to take the output of XOR gate 1 and connect it to the first input of XOR gate 2. The output of XOR gate 1 is pin number 3. So I connect, first I'm going to bend this wire so that I can more easily connect the two gates to each other. One sec. Okay. Now, pin number 3 is going to have to be connected to pin number 4. There we go. As you can see, pin number 3, the output of XOR gate number 1, has been connected to pin number 4, which is the first input of XOR gate number 2. Now, XOR gate number 2 is also connected to VCC power. So in order to do that, I'm going to have to connect pin number 5 to power. There we go. Pin number 5 is connected to power. Looks like we've set up our basic circuit. Now, next I need to connect switch 1 to input A and connect switch 2 to input B. So input A of our circuit is pin number 1 and input B is pin number 2. So I'm going to connect switch 1 to input A. So connect switch 1 to pin number 1. Next, I'm going to connect switch 2, input B, to pin number, switch 2 to pin number 2, which is input B. There we go. Now I connect the output to an LED. Output Z, in this case, is actually going to be pin number 6. So I'm going to connect pin number 6 to LED 0. Now let's see if I did this right. It's time to use our truth table and perform the experiment. So situation 1 of our truth table is A should be up, A should be down, and B should be down. 0 means down. So I switch A, which is 1, down, and 2, which is B, down. And then turn on the power. Looks like our LED is on, and so I can write a 1 for this situation. Next situation, A is down and B is up. A is down, it already is, and B should be up. Looks like our LED is off in this case. That means that I can write a 0 for this situation. A is up, B is down. A up, B down. The LED is off in this situation. That means that I can write a 0. A up, B up. A up, B up. In this case, the LED is on, which means I can write a 1 for this situation. Okay, I'm going to build the third circuit for experiment number 6. So, in this case, I'm going to be constructing figure 6.3. This has 2 XNOR gates connected to an AND gate. Unfortunately, I don't have XNOR gates in my set, so I'm going to have to instead substitute XOR gates, 2 XOR gates for each XNOR gate, just like in the diagram for figure 6.2. For figure 6.2, we created a circuit which reflected the characteristic of a XNOR gate out of XOR gates. So we're going to use that same technique here to create this circuit for figure 6.3. Okay, so first I'm going to construct my first XNOR gate. So I connected pin number 3 of chip 7486 IC, which is the XOR gate chip. I connected pin 3 to pin number 4, which is the output for the first XOR gate, being connected to input 1 of the second XOR gate. And input 2 of the second XOR gate is connected to power. Next, I'm going to connect pin number hold on, I'll get right back with you. Okay, so I connected pin number 11 to pin number 10 because pin number 11 is the output of the third XOR gate, and pin number 10 is the first input of the fourth and final XOR gate. Okay, and then I connected pin number 9 to power because that is the second input of the final XOR gate. Next, I need to connect both pairs of XOR gates to input 1 and input 2 of the AND gate. Okay, so I connected pin number 6 of the XOR gate chip to pin number 1 of the AND gate chip. Pin number 1 of the AND gate chip is input 1 of the first AND gate. The only AND gate that we're going to be using in this example. Okay. Pin number 8 was connected to pin number 2 of the AND gate, which is the second input for the AND gate. Next, let me define some things. Pin number 1 is A1. Pin number 2 is input B1. Pin number 13 is input A2, and pin number 12 is input B2. So A1, B1, A2, B2. So I want to connect A1 to switch 1. A1, pin number 1, to switch number 1. A2 is going to be connected to switch number 2. So pin number A2, pin number 13 is going to be connected to switch number 2. Next, B1 is going to be connected to switch 3. So B1, that's pin number 2, is going to be connected to switch number 3. There we go. And B2, that's pin number 12. Is going to be connected to switch number 4. There we go. And finally, we have to connect output Z, which is the output of the AND gate, which is pin number 3 of the AND gate chip. We connect that. Sorry, it's kind of bent. We connect that to LED 0. There we go. So, this rather complicated looking circuit should hopefully produce the outcome that we're expecting. Let's turn on the power. Now, situation 1 is A1 down, A2 down, B1 down, B2 down. Remember that switch 1 is A1, switch 2 is A2, switch 3 is B1, and switch 4 is B2. So A1, A2, B1, B2. All of them should be down at this point, and they are. The LED is lit. This means that we can write a 1 for this situation. Next situation, A1 is down, A2 is up, B1 is up, B2 is up. So, A1 should be down, A2 should be up, B1 should be up, B2 should be up. In this case, the LED is not lit. This means that we can write a 0. A1 is up, A2 is down, B1 is up, B2 is up. So, A1 is up, A2 is down, B1 is up, and B2 is up. The LED is not lit. In this case, we write another 0. Last situation. A1 is up, A2 is up, B1 is up, and B2 is up. So all switches are up. And the LED is lit. So we can write a 1 for this situation. Our results show that this circuit actually behaves like a giant XNOR gate, which only produces a high when all of its inputs are the same.